Welcome back to Algebra 2 Easy. Let's prove continuity. Here you're given a piecewise function and you have to determine if the function g of x is continuous at x equals 0. The first rule of proving continuity is proving that f of x actually exists at that value. If it doesn't exist, then you don't need to go any further and the function is not continuous. So let's figure out if f of x is continuous at 0. So looking at our piecewise function, we look at all the restrictions and we're looking for where 0 is. We can see x is less than 0 and x is greater than 0. So you're looking for the equal to. So where x is equal to 0 is that middle piece. So I'm going to use the square root of 1 minus 0 squared. So you're just going to plug your x value into that particular piece and then simplify. I get the square root of 1, which is equal to 1. So we can say f of 0 equals 1. So our x value has passed the first rule, and we can move on to the second rule. Now the second rule states that the limit as x approaches 0 of the function must also exist. And as I'm writing this, I'm realizing that my piecewise says g of x, and I've been writing f of x, so you'll have to excuse me. All right, so the limit as x approaches 0, because you don't have one single piece of the piecewise that is approaching 0, you have two pieces. A left piece, which is x values to the left of 0, and a right piece, x values to the right of 0. So we're going to have to split this up into two limits. Looking at the left limit first, so the limit as x approaches 0 from the left, so you're looking at the piece for x values to the left of 0 or less than, and that piece is just simply 1. So there's actually no work to do there. The limit as x approaches 0 from the left is equal to 1. Now let's look at the limit as x approaches 0 from the right. So again, we're looking back at the piecewise and we're trying to figure out which piece would include x values to the right of 0. And as we can see, that's going to be the middle piece, the square root of 1 minus x squared. And again, it's kind of like rule 1, where you're going to plug in 0 for x. And I end up with the square root of 1 minus 0, which gives me the square root of 1, which is equal to 1. So now we can see that the left limit as x approaches 0 from the left is equal to 1. And the right limit is also equal to 1. That means the limit as x approaches 0 as a whole exists, and we've just proven rule 2. Now moving on to rule 3, which states that f of 0 must equal the limit as x approaches 0. So in short, the first rule and the second rule, those two answers have to be the same. Looking back at the first rule, f of 0 was equal to 1. And then looking at the second rule, our limit was also equal to 1. So we could say 1 equals 1. Now, if that's a true statement, then the third rule has passed and you have proven continuity, just like we did here. All three rules passed, so it is continuous. I hope this helps, and be sure to follow us for more.